Hello again, everybody, and welcome to video 2 in our Systems of Linear Inequalities series. Today is going to be another skill review. We're moving on from lines, though, and we're going to look at graphing linear inequalities. First thing I want to talk about is an equation versus an inequality. So, let's just draw a line down the middle here. An equation. An example of an equation would be 2x minus 4 equals 10. In the equation, you solve for x. So add 4. 2x equals 14. Divide by 2. Divide by 2. X equals 7. So there's only one possible answer. 7. 7 is the only thing that would make this work. So if I checked it, I have to place a 7 in that minus 4. Sorry about that. I have to place 7 in where my x was. And that's the only way my left and right side will equal each other. So that's 14 minus 4 equals 10. 10 equals 10. It checks out. If I was to graph it on a number line, I'll put my answer in the middle there. 7, so this is 8, 9, 6, 5. The only thing I would shade in, or the only dot I would make, is on the 7. So that's an equation. Let's look at an inequality now. Okay, an example of an inequality. Let's look at the exact same situation. 2x minus 4, but now I need an inequality sign. So I'll say 2x minus 4 is less than 10. When you're solving an inequality, you treat it actually like an equation. So I'm going to still isolate the x, all right? The only thing you have to remember is to change your sign when you divide or multiply by negative. So change sign, and what I mean that is just really the direction. When multiplying or dividing by a negative number. Okay, so that's important. So you don't really have to change your sign very often, but it does occur. So I'm going to add 4. Add 4. So I didn't divide or multiply by negative, so I keep my inequality sign facing the same way. That's 14. Divide by 2. Divide by 2. I'm dividing, so it's possibility, but it's a positive number, so I don't have to change the sign because it's a positive number. So that's saying x is less than or equal to 7. So that would mean any value that is less than, I said less than or equal to, didn't I? That's x is less than 7. Anyway, to check this, any value that is less than 7 will work. So 6, 5, 4, 3, 2, 1, whatever. So let's check this real quick. So I can check it using something else. Let's say I'm going to check it with x is 5. So that's less than 7. So 2 times 5 minus 4 is less than 10. 10 minus 4 should be less than 10. 6 is less than 10. So there's a range of values. Let me just show you one more. Where could I sneak this in? Let's try to sneak it in right beside. Let's say x is negative 1, because that's less than 7. 2 times negative 1 minus 4 is less than 10. Negative 2 minus 4, less than 10. Negative 6 is definitely less than 10. So in both these cases, they were values under 7, and they both worked. So I get a range of answers. So an equation is very precise. One thing works. An inequality, there's a range. So an inequality is more of a general thing. If I'm to graph this on a number line, to highlight my answers, I'll put 7 in the middle again, 8, 9, 6, 5. Well, I would highlight the 7, but my answer is not allowed to be 7, so I actually would just put an open circle on it. I wouldn't shade it in like normal. If it's ever an equal to, then I shade in. We'll go over those signs later in the video. And then I'm saying any answer less than 7, or any value less than 7, we would count as an answer. So I'd shade in all the different values on my number line that are less than 7. And then I'm going to make that left arrow really big because it would go on forever. So I just tested 2 whole numbers when I checked, but all the fractions in between would work too. So 5.5 would be an acceptable answer and things like that. Okay, so hopefully that highlights the difference between an equation and an inequality. Okay, so let's review quickly the inequality signs and then the type of line that results from it. So the first thing, I guess, let's pick a color. That's the first thing I should do. X is greater than, I guess I'll say 7. So this is greater than. Okay, so if it is greater than, it's going to result in, if we're drawing, if that's contained in a linear inequality, so something we're going to graph, it would be a dotted line or a dashed line. Okay? X is less than 7. So that's less than. By the way, we always read it left to right. So once again, we're going to have just this dashed line. X is greater or equal to 7. Okay, so that sign is greater than or equal to. Whenever we have an equal to, we get to draw a solid line. So the equal to, as soon as you have an equal to, you have that solid line. Now the last one would be less than or equal to. And once again, a solid line. Now the other thing I want to talk about while we're here is what happens when these things intersect. What we're going to be doing is we're going to be looking at, sorry, I lost my train of thought there. What we're going to be doing later is we're going to be looking at systems and when they intersect. So I guess really I can leave that until I do my systems video. That's why I paused there for a second. I'd kind of gotten ahead of myself. So for right now, this is all we need to know. When we're graphing these linear inequalities, it's either going to be a dashed line or a solid line. All right, so as with before, we have this very formal notation. But it's broken up into those same 3 parts. So the red part is really your introduction. It just explains that this set is talking about some points. These points follow this pattern or rule. So this is our pattern or rule. It's our inequality, really. And then the blue is just telling you, is it discrete or continuous data? So we still have that going on, and that's going to involve our shading. So I'll have to explain that a little bit more. But if it's real numbers, we can draw a solid line first of all. And then we can shade in later on. And what am I talking about when I'm saying shading? I'll tell you in a minute. Okay, so the nice thing is when you're graphing a linear inequality, pretend it's just an equation. So graph it like a normal line. So negative 3x plus 4y is less than or equal to 12. But I'm going to treat it like a normal line, meaning I'm going to actually try to rearrange this into y equals mx plus b. But instead of an equals to sign, we'll have an inequality sign. So first thing I'm going to do is move that x. You always perform the opposite operation to move it over. 4y is less than or equal to 3x plus 12. Now I'll isolate that y by dividing by 4. Now again, you've got to watch that when you divide or multiply by a negative, you've got to change the direction of that sign. I'm dividing by a positive, so I have nothing to worry about. Okay, so now I've converted this inequality into that y equals mx plus b form. Same idea, so my slope is 3 over 4, and my y-intercept is positive 3. So when I graph, same idea as the previous video, I put my 3 down first, and then I use that slope to get to my second point. So I'm going to go up 3 more, 1, 2, 3, and then over 4, 1, 2, 3, 4. All right, now before I draw my line, I'm just going to double check. That is it says less than or equal to. So equal to means solid line. So I'm going to draw a solid line. And then there's one more step with inequalities. With an inequality, you have to then shade to represent that range of answers possible. Because now we're not just looking at a value of x, but we're looking for this combination of x and y that would fit this pattern or rule, this negative 3x plus 4y is less than or equal to 12. So how do I know which side I shade? Well, what we do is we take a test point. You take any point you want from the coordinate plane and plug it into this inequality to see what the result is. Now the test point that I always want people to use, or I feel is the smartest one, is the origin 0, 0. It's a point and it's 0, so like there's no math, or sorry, like the calculations are really, really easy. And it's just, yeah, it seems like the least amount of work always. So I'm going to plug this in. So here's my test point. So this is kind of part 1, I guess, to put some steps down, the graphing. Part 2 is my test. And my test point is this 0, 0. I take my inequality from my set up top there. -3, I'm going to replace the x with 0, plus 4 times 0 is less than or equal to 12. -3 times 0 is 0, plus 4 times 0, which is 0, so they're both 0. So then I'm left with this statement, and I have to interpret it. If this is true, then that means the test point is in the solution region, and I would shade that region, that side of the line. If it's false, that means that test point is not in the solution region, so I shade the other side of the line. So 0 is less than or equal to 12. Is 0 less than or equal to 12? It is. So this is a true statement, meaning that the origin is in the solution region, so I shade everywhere to the right of this line, like so. So now you can shade it however you want. I just like drawing lines perpendicular to this line I just drew, and that is how you graph an inequality. Now, if that doesn't quite make sense, the shaded area, any point selected from that shaded area is going to result in a true statement when I plug it in, like my test point. If I was to take a point from the non-shaded area, so for example, if I took a point like up here, so that is -4 and 6, if I plug that in, the result would be not true. So it might be something like 14 is less than or equal to 12. That's not true. All right, so that is how you graph an inequality. It's very much similar to graphing a line. Really, we just have to watch the type of line we draw and then the shading. Again, check out that formal notation at the top. We can kind of ignore the first part, focus on the second and third parts. So the second part is going to be, that's the inequality we're graphing. The third part is real numbers. So again, it's telling us that we have a solid line. And then we can do simply that shading. If it's so that's continuous data. If it's discrete data, the shading turns into dotting. So which is annoying, because imagine how many dots you'd have to draw there. So it's nice when you see that solid. So we get to solid, we have the solid line, and then we get to shade in that kind of lazy fashion I showed you in the previous example. So step 1, we're going to worry about this line. So 3x minus 5y is greater than or equal to 15. Once again, I want to rearrange this into slope-intercept form, so I'm going to isolate that y. So subtract 3x, subtract 3x. Negative 5y is greater or equal to negative 3x plus 15. Then I divide by negative 5. And finally, here's an example. I said a couple times, when you divide by a negative number like I'm doing, we have to change the direction of the sign. So y is now less than or equal to positive 3 over 5x minus 3. I can show you later, maybe I'll try to show you later, because I don't know if I have the room here in this question, why we have to do that. So if I have enough room on this slide, I can do that for you. But let's keep moving. So now I've got it in that y equals mx plus b. My slope is 3 over 5. My y-intercept is negative 3. So I'll put my negative 3 down first. Then I go up 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. So again, these just happen to be the intercepts as well, which isn't a good or bad thing, just a thing. Double check, yeah, I'm drawing a solid line. The reason I know it's a solid line, sorry, is that I have this right here as well. There we go. So the fact that they're real numbers from the real number family allows me to draw the solid line, and the fact that we have the inequalities there with the equal to. All right, so the next thing we have to do is we have to shade. So with the shading, again, because right now that's like graphing a normal line. So what makes it an inequality is when we have to have that, when we shade in that solution region, which shows you there's a range of answers that would work. So my test point again is going to be 0, 0. I'm always going to use 0, 0. And again, 0, 0 is right here, of course. If it works out, I shade that side. And if it doesn't work out, I'll shade the other side. So 3 times 0 minus 5 times 0 is greater than or equal to 15. So yeah, I go back to the original inequality. I'm not going to keep my sign flipped. Remember, this one was flipped, but that was flipped in that calculation I did. Whenever you start a new calculation, you start from scratch again. So I'd restart. That is going to be 0 minus 0 is greater than 15. 0 is greater than or equal to 15. Is that true? No, that is false. So that means I'm going to shade the other side of this line. So I'm not going to shade the test point region. I'm shading the other side. Okay, so again, that would mean that if I highlighted this point here, that would be an answer. That's going to result, if I checked it out, it would result with the left side being true to the right side, whatever the inequality relationship is. But if I chose something outside the solution region, like this red dot, it would result in the same way that test point did, where I'd have some false answer. Third example. So things to notice. I have only one variable in that equation, or inequality, so we've handled those before. And then right here I have integers. So what that's going to mean is I'll have to use a dotted line if I have an equal to, which I do. And then I'm going to actually have to do some dot shading as well, which is not fun, people. It's not hard, especially when you have graph paper. If you don't have graph paper and you're just sketching this stuff, it's really annoying. But if you have graph paper, it's fine. Okay, so step 1, we're going to get this line drawn. So it's already isolated, people. So that's a really quick and easy one. Y is greater than or equal to negative 3. Hopefully remember that when it's y equal to, that it is a horizontal line. So I'll get that going. And now I almost drew a solid line. I have to make this a dotted line. So I don't need my ruler even. So I just dot these lines, these points, I'm sorry. Again, we can't connect the dots because the values in between the dots don't exist in this number system. So there is my dotted line. So now there's nothing different so far from a line and inequality. What makes the difference is that shading. So I'm going to do the same idea. I'm going to, this is my shading title. And I'm going to test this 0, 0. And so I'll highlight that on my graph as well. So 0 is greater than or equal to negative 3. Is that true or false? That's true. 0 is bigger than negative 3. So that means I would have to shade in the test points region, which you can see is going to be a lot of points. I can't just draw the line, because if I draw those lines, that's going to mean all the different decimals actually count as well. So I'm not going to take the time to dot all of these. But if you're doing like a perfect job, you would do that. You would shade all this stuff. On your test or quiz, don't worry. If you have one of these, I will not have like 100 dots like this or whatever it ends up being. So I'm going to stop here after this next row. And you can see all of these points are valid answers. While I have some room here, why don't I go into that really quickly, why I have to change the direction of the inequality sign. So I'll do that right here. If you have some sort of statement like 5 is greater than 3, okay? Remember, we can adjust, or you may not know, inequalities you can adjust like equations. So as long as I do the same thing to both sides, it's fine. So if I times both sides by 2, a positive number, I would get 10 is greater than 6. So that's still true. If I did the same thing but I multiplied by a negative 2. Negative 2 times 5, and then negative 2 times 3. That'd be negative 10 is greater than negative 6. So in this one, it was true, but that is false. Negative 10 is not bigger. So the only way we can actually make that true is by flipping the sign. So that is why we have to change that sign. In summary, to graph the solution set of a linear inequality, first graph the boundary. So that boundary is the line I was talking about. And I should have used that language a little bit more. It's called the boundary because it separates what are answers from what are not answers. And there you can see a quick recap of, depending on your inequality sign, the type of line you'll have. So you can pause the video if you want to read that. And then underneath it says to complete the graph of the solution set, it talks about how to shade. So again, you can pause the video and read that if you like. If this made sense, that's great. If it didn't, make sure you talk to your teacher or come find me. Have a great night, everybody.